Now we're going to start solving equations that have two steps or possibly more in them. So we kind of have to use our order of operation in the reverse most of the time. There are a few exceptions to that. Get rid of anything being added or subtracted first, then get rid of anything being multiplied or divided. So if we want to solve this equation, we again find our variable. That's the side we're going to start on, and it's being multiplied by 7 but also subtracted 17 from it. So I'm going to do the opposite of subtracting 17, which would be to add 17. You do one step at a time and then you work each side. So the 17s undo each other, leaving me 7x, and I do the math over here, 77. The variable is still not by itself, which is our goal. So now we're going to do the opposite of multiply by 7, which would be divide by 7. And we get x equal 11. Again, we can check that by replacing right here this variable, so it becomes 7 times 11 minus 17. 77 minus 17 is 60, so it does check out. So I don't make you do that, but that's available to you. Don't forget about that. It would be good for a test. Problem 2, again, find the side with a variable. We want to get rid of the 8 and the 21, so we're first going to get rid of the 21. It's being added, so the opposite would be subtract. We get y over 8 equals, again, you use your change, or add the opposite. You're going to get negative 7 over here. The opposite of divide by 8 would be multiply by 8. Show it up here, and you're going to get y equals negative 56. The signs are different, so your answer is negative. Again, we want to get rid of the numbers with the variable, so we're going to add 13 to each side. 5x equals 50. And the opposite of multiply by 5 would be divide by 5. Get x equals 10. The opposite of subtract 9 would be add 9 in problem 4. Get y over 12 equals, here my signs are different, so I need to use my rules, which means subtract and keep the sign of the bigger number. So it's going to give me negative 2. The opposite of divide by 12 would now be multiply both sides by 12, so we show it out here. These cancel, and we get y equals negative 24. Now this is a problem where the fraction bar is like a grouping symbol, so we have to undo it first. This would be the example of where we don't do something and get rid of adding and subtracting. So the opposite of divide by 9 is multiply by 9, so I'm multiplying both sides by 9. These 9's cancel, just leaving me then p minus 15 equals negative 54. And now it's just like what we were doing. The opposite of subtract 15 would be add 15 to both sides. Signs are different, so we're going to subtract our numbers. Keep the sign of the bigger number. Negative 39. Kind of ran into my equal sign there. On this problem, the opposite of divide by negative 3 would be multiply by negative 3. So I'm going to multiply each side by negative 3. The negative 3's cancel, leaving me r plus 8 equals positive 6, because we're multiplying, the signs are the same. So we would like to subtract 8 then from each side to get the variable by itself. Get r equals negative 2. Solve this equation. We want to get rid of the 6 first. It's a positive 6, so we're going to subtract 6 first. Now remember, this negative sign has nothing to do with the 6, so don't let that confuse you. When we do that, we're left with negative x over 2 equals negative 2. I like to think of this negative sign as being in the denominator with my number. You can write it anywhere, but so I'm going to think of it here. And so I'm going to multiply both sides by negative 2. If you don't do that, you'll have to do an extra step. So I get x equal 4. So if you left the negative sign up above and multiplied both sides by 2, you would get negative x equal negative 4. And then remember, it's like having a negative 1 there, so you would have to divide both sides by negative 1 to get x equal 4. So you can do that problem either way.